You're looking at Venus through a telescope for the first time. It's beautiful, bright, radiant, shining like a pearl in the evening sky. The Romans called it the goddess of love. Astronomers call it Earth's twin. Same size, same mass, same rocky composition. You can almost imagine a tropical paradise hidden beneath those brilliant white clouds. Then you learn what those clouds are actually made of. Sulfuric acid, battery acid, swirling across the entire planet. And beneath them, hell. The surface temperature is 880 degrees Fahrenheit, hot enough to melt lead. The atmospheric pressure, 93 times Earth's, the kind of pressure that would crush a human instantly. The atmosphere itself, 96% carbon dioxide. If you somehow survived the heat and pressure, you'd suffocate immediately. This is Venus today, Earth's twin. How did two nearly identical planets end up with such opposite destinies? In 1975, after countless failed missions, the Soviet Venera 9 accomplished the impossible. It survived descent to Venus and sent back the first photograph from another planet's surface. Rocks. Flat, broken slabs of volcanic rock under an orange sky. No oceans, no life, just desolation. Venera 9 lasted 53 minutes before its electronics melted. In 1982, Venera 13 returned color photographs. Orange-brown rocks stained by iron oxides, an eerie amber sky sunlight filtered through sulfuric acid. It looks like the edge of a volcanic eruption, except there's no escape. The entire planet is like this, forever. Venera 13 survived 127 minutes, 2 hours. That's how hostile Venus is. So what the hell happened? The answer is the runaway greenhouse effect. And understanding it might be the most important thing humanity needs to know. 4.5 billion years ago, Venus probably looked like Earth. Blue skies, liquid oceans, white clouds. Scientists believe Venus was habitable for up to 2 billion years. Back then, our sun was dimmer. Venus sat in the Goldilocks zone, not too hot, not too cold. But stars gradually brighten, about 1% every 100 million years. As the sun brightened, Venus received more heat. The oceans began evaporating. Water vapor, a powerful greenhouse gas, accumulated in the atmosphere. And here's where the feedback loop kicked in. More water vapor traps more heat. More heat causes more evaporation. More evaporation means more water vapor, spiraling out of control. This is the runaway greenhouse effect. Once it starts, there's no stopping it. Eventually, the entire ocean evaporated. Surface temperatures hit over 2,000 degrees Fahrenheit, hot enough to melt rock. The planet became a steam-covered inferno. In the upper atmosphere, ultraviolet radiation broke apart water molecules. Hydrogen escaped to space. Oxygen reacted with rocks. Over millions of years, Venus lost its water. All of it, gone. We know this happened because of deuterium, heavy hydrogen. Venus has 150 times more deuterium relative to regular hydrogen than Earth. Why? When hydrogen escaped to space, the lighter isotope escaped easier. Deuterium got left behind. This is the smoking gun. Proof Venus once had oceans. Without water, plate tectonics stopped. On Earth, water helps tectonic plates move. On Venus, the surface locked up. And plate tectonics regulate atmospheric carbon dioxide. CO2 from volcanoes gets absorbed into rocks and buried back into the mantle. A natural thermostat. On Venus, no carbon recycling. Volcanic eruptions kept pumping CO2 into the atmosphere. It just accumulated. Over billions of years, 96% CO2, the greenhouse effect locked in permanently. A furnace. Here's what should terrify you. Venus failed because of its position, just close enough to the sun that when solar brightness increased, it crossed a tipping point. And once that tipping point was crossed, the feedback loops became irreversible. Scientists call this the inner edge of the habitable zone, the nightmare. As our sun continues brightening, Earth will eventually approach that same edge. One day, maybe a billion years from now, Earth will experience the same water vapor feedback loop. Our oceans will evaporate. The runaway greenhouse will begin. But Venus teaches us something more immediate: how fragile planetary habitability is. Think about it. Venus and Earth are twins. Same size, same composition. The only difference? Venus is 5% closer to the Sunday. 5%. That tiny difference doomed Venus to hell. That's how narrow the margin is. And we're running a global experiment to see how much we can push Earth's climate before triggering irreversible feedback loops. We're pumping billions of tons of CO2 into the atmosphere every year. Ice sheets collapsing, oceans warming, weather destabilizing. We won't turn Earth into Venus soon. Our massive oceans provide damping. But we're pushing boundaries, testing limits. And history shows what happens when you push planetary systems too far. Venus isn't just a cautionary tale from the past, it's a warning for the present. In 2026, multiple space agencies are planning missions to Venus. Da Vinci will analyze atmospheric gases. Veritas and Envision will map the surface. Rocket Lab's Morning Star mission is testing whether microbial life might exist in the cloud layers. Why go back? Because Venus holds answers. Did it have oceans? How long were they stable? When did the runaway effect start? Can we detect warning signs on exoplanets? We've discovered thousands of exoplanets, many Earth-sized, in their star's habitable zone. The question isn't just, are they habitable? It's, did they suffer Venus's fate? Statistical models suggest Venus-like runaway scenarios might be disturbingly common. Earth might not be the rule. Earth might be the exception. We live on a fragile exception. A planet that got lucky. A world that formed just far enough from the sun, with just the right water, with plate tectonics that stayed active, with life that helped regulate the atmosphere. We're walking on a tightrope, and Venus is what's waiting if we fall. So the next time you see Venus in the evening sky, brilliant and beautiful, remember what it represents. Not just a failed twin, a mirror, a warning, a planetary tragedy frozen in time. A world that started like ours and ended in hell. And it's asking us a question we can't afford to ignore. How much do we want to be like Venus? Saturn is beautiful. Neptune is chaos. But Uranus? Uranus is something else entirely. It hangs there in the outer dark, pale, featureless, silent, no swirling storms, no grand rings catching the light, just a smooth, cold sphere drifting through the void like something that forgot how to live. And that's exactly what makes it the most terrifying object in our solar system. The crime scene. Look at it closely. Something is wrong. Every other planet in our neighborhood spins like a top axis, roughly upright, poles pointing up and down. But Uranus, it rolls on its side like a corpse tumbling through space, tilted 98 degrees from vertical. This isn't some gentle quirk of formation. This is evidence. Scientists believe that billions of years ago, something massive, perhaps twice the size of Earth, slammed into Uranus with such catastrophic force that it knocked the entire planet onto its side. A planetary murder. A collision so violent it should have shattered everything. But Uranus didn't shatter. It survived. And that survival created something far worse than destruction. The seasonal nightmare. Uranus takes 84 Earth years to orbit the Sunday. Because it's spinning on its side, each pole faces the sun for 42 consecutive years. Let that settle in. Imagine being born on Uranus's North Pole during summer. The sun hangs above you, dim, distant, but there, for your entire childhood, your entire education, your career, your middle age. That pale star never sets. Then, as you approach old age, it begins to sink. And for the next 42 years, the entire second half of your life, you live in total darkness. No dawn, no sunset, just an endless, frozen night where temperatures plummet to negative 224 degrees Celsius, negative 371 degrees Fahrenheit, and the only light comes from distant stars and the planet's faint, broken rings. This isn't a season. This is a geological epoch of darkness, the dead interior. Here's where it gets stranger. Every other gas giant radiates more heat than it receives from the Sunday. Jupiter glows with internal warmth. Saturn does too. Neptune is a furnace of residual formation heat. But Uranus? Nearly nothing. It absorbs sunlight and releases almost no internal heat, as if something inside went cold long ago. Scientists don't know why. The leading theory? That ancient collision didn't just knock Uranus over. It may have ejected its core heat into space, leaving behind a frozen shell of methane, water, and ammonia ice, compressed into exotic states of matter we can barely simulate on Earth. Deep inside, beneath clouds of hydrogen sulfide, the same chemical that gives rotten eggs their stench, the pressure becomes so extreme that scientists believe carbon crystallizes out of the atmosphere and rains down as diamonds, sinking slowly through layers of superheated ice that remains solid under crushing gravity. A planet that smells like decay, raining gemstones into an ocean of ice that never melts. The shattered court. Uranus has 27 known moons. Most are named after Shakespearean characters: Oberon, Titania, Ariel, Miranda. But these aren't elegant celestial dancers. They're wreckage. Take Miranda. When Voyager 2 flew past in 1986, the only spacecraft to ever visit it photographed a moon that looks like it was broken apart and reassembled. Massive canyons 20 kilometers deep scar its surface. Cliffs so tall that if you jumped off one in Miranda's low gravity, you'd fall for 10 minutes before hitting the ground. Scientists think Miranda may have been shattered by a collision, then pulled back together by its own gravity. A moon that died and came back wrong. And it's not alone. Uranus's moons orbit in a system so chaotic, so gravitationally unstable, that computer models suggest they may be on collision courses with each other in the distant future. This system is still breaking. The rings of evidence. Uranus has rings, 13 of them, but unlike Saturn's bright, icy bands, Uranus's rings are dark, made of radiation-scorched particles, likely the pulverized remains of moons destroyed long ago. They circle the planet vertically because Uranus is lying on its side, creating a structure so alien that early astronomers thought their telescopes were malfunctioning. These rings don't shine. They absorb light. They're not decoration. They're a graveyard. The loneliness. We've sent 5 spacecraft to Jupiter, 4 to Saturn. Even Neptune got a visit. Uranus? One flyby, one brief encounter in 1986, a handful of blurry images, some measurements, and then Voyager 2 continued into the dark, never to return. No orbiter, no lander, no return mission planned. Uranus remains the least explored planet in our solar system, not because it's unimportant, but because it's so far, so cold, so unrewarding to our instruments that we've collectively looked away. It drifts out there, 2.9 billion kilometers from the sun, rotating on its broken axis, exhaling clouds of hydrogen sulfide into the void, waiting for no one. The thing about corpses, here's what we forget. Corpses tell stories. Uranus isn't boring. It's a scar, a record of violence so ancient we can only reconstruct it from the wreckage left behind. It's a planet that was murdered and survived, but the survival changed it, made it cold, made it wrong, and it's still out there, rolling slowly through the outer dark. Its rings made of shattered moons, its core a frozen enigma, its seasons measured in human lifetimes, a pale, chemical-reeking tomb spinning on its side, alone, waiting, and utterly, profoundly indifferent to whether we ever come back